In this video, we're starting our graphs of the rational functions, and the focus that we will be going over in terms of characteristics of these graphs will now be with our rational. We're still going to have our zeros, so we're going to have our roots, our solutions, but now we're going to also talk about asymptotes. So we're going to bring up what is the asymptotes of graphs, as well as what is the hole in the graph. So again, the zeros, or as we're referring to the zeros as our roots, we could call them our solutions. We could also say, according to the graph, that these are the x-intercepts, right? So all of these refer to our zeros. So that is where we have the x value that makes the numerator equal to 0. So the zeros, we're going to be focusing on the numerator. Now, the vertical asymptote, so this is something new that we're bringing up. So vertical meaning up and down. And then here, we're going to focus on how do we find the vertical asymptote? We're going to focus on using the denominator. Then here, whenever we had the rational expression where we could cross out a value, like the x minus b or x plus b, in both the numerator and denominator, we're going to refer to that value as our whole. Now, this will also give us what the x value of the whole is. So for example, when we ever had, let's say, x squared minus 9 and x squared plus, let's just say, what can we do? 3x plus 4. Nope. Let me switch it up. Oh, I got it. X squared plus 2x. Wait, what am I trying to get here? Oh, no, I was right. X squared plus 4x plus 3. So here you would factor this, right? I've got x plus 3 times x minus 3. And then we would factor the denominator into x plus 3 times x plus 1. So then we would go, okay, well, how can I simplify this? Well, I see that x plus 3 is in both the numerator and denominator. So we would then cancel these out. This is going to represent the x value of what we're going to call the whole in our graph. So in this case, x is equal to -3. That is the x-intercept of the whole. So what do we mean by all of these? What does this look like in a graph? So for example, we're going to identify these, but I graphed this first example to show you this function and what it looks like. So here, that first function looks like this. So notice how, if I also wanted to zoom out a little bit, it's almost like disconnected. So see how here it's like approaching but never reaching this horizontal line, and we'll talk about horizontal next. And then here, the up and down. It's like the graph gets closer and closer but never reaches where x is equal to 5. Then here, notice how we do have our solution, the x-intercept, where x is equal to 2. So we have a 0 at x is equal to 2. We have this invisible where it's never going to reach x where it's equal to 5. Now, in Desmos, you cannot see the whole, but the whole is literally going to be on the graph. So like, for example, here, you would actually see literally, because you can't really see it, but it would actually be a hole where the graph stops and then continues on. So that is what we're referring to as the whole of this graph. So now let's actually go through and see how we would calculate. So again, always focus on factoring. I'm going to go ahead and factor the numerator. So here I've got the difference of two perfect squares. So this is x plus 2 times x minus 2. Then I'm going to factor the denominator, which here I have x minus 5 and x plus 2. So now notice that here we have that common factor, right, in both the numerator and denominator, x plus 2. That means that the whole is at x is equal to -2. Because again, we're setting this up, x plus 2 is equal to 0 and solving for x. So the x coordinate is -2. Now we're going to kind of put that to the side because the x coordinate is 2 to show you how we're going to get the y coordinate. So now once we have the whole here, I can go ahead now and cancel out. Now remember, the numerator always gave us the 0. So that's how here our 0, and if you recall, we'll go back to the graph, is at x is equal to 2 or 2, 0. Then the vertical asymptote comes from the denominator, where here, so the vertical asymptote is x is equal to 5. So that is an actual line here where x is equal to 5. If you go back, see, we had 2, 0, and the graph never reached 5. So that's how we're going to identify. So now how do we get the y coordinate? Well, we actually are going to take the x and plug it back into what was left over after we canceled out and simplified. So if we simplified and had x minus 2 over x minus 5, we're now going to plug in for x, -2. -2 minus 2 and -2 minus 5. So that means I've got here -4 over -7, but two negatives make a positive. So the whole is located at the point -2 and 4/7. You can't see it when we graph this in Desmos, but that's where you would have a hole in the graph. So this is what we're going to be focusing on here, guys, is identifying the hole, the 0, and the vertical asymptote. So let's go ahead and take a look at this U-try, but before you do, I'll show you the graph of it. So here's our graph. So notice how we're kind of getting closer and closer to this line here where x is equal to 2, but never reaching it. Then here we have 2 zeros now. So if you notice, we have -1 and 3. Now we can't visually see the 0, so we'll have to calculate that. But go ahead and try that U-try now on your own and see if you end up with that vertical asymptote as well as 2 zeros. And here we go. So again, always focus on factoring, right? So I can factor my numerator. So this is x minus 3 times x plus 1 over x minus 2, nothing you can do. Now remember, the whole is always what common factors we had. Well, what do you notice? Nothing canceled out. So guess what that means? Do we have a whole? Sure don't. So there is no whole, none. That means now we can get right into, remember the numerator was your zeros and the denominator was the vertical asymptote. So that's how we have both zeros here, 2 zeros. X is equal to 3 and -1, or 3, 0 and -1, 0. Then we have our vertical asymptote at x is equal to 2. So there's your line where they continue on focusing here. The same thing again. Let's identify. Always focus on factoring first. So let's factor. Here I have x plus 6 times x minus 2 over x minus 5 times x minus 2. Now notice we do have a common factor. So that is what we would cancel out, and that's going to represent our whole. So the whole of the graph is at x is equal to 2. So the x coordinate is 2. So now let's continue. I would cancel those out, right? And we're left with x plus 6 over x minus 5. That would be the simplified form. Now remember, the numerator was always the zeros and the denominator was always the vertical asymptote. So here we have 1, 0 at x is equal to -6, or at -6, 0. We have our vertical asymptote at x is equal to 5. So we're saying that the graph would approach that. Then let's also get the y coordinate, right? By taking our x and plugging in 2 because x is 2. So 2 plus 6 over 2 minus 5. So now I have 8 over -3. That is the y coordinate. So now let's check the graph. We can't really see the 0, but see if we have the 1, 0 at -6 as the graph is approaching 5. And here we go. So I see here, I'll zoom in. I see here, yep, we have our 1, 0 at -6. Then I can zoom out. Notice how here our graph is approaching but never reaching x is equal to 5. So notice I can keep going and going, and it gets closer and closer, but never reaches where x is equal to 5. So go ahead now and pause the video and try and identifying the zeros, the vertical asymptote, and hole, if there is any, on your own. And here we go. So again, always focus on factoring. I've got in the numerator x plus 3 times x minus 1. And in the denominator, oh, we got it, sorry, that was supposed to be a plus 12. So x squared plus, I'm sorry, not x squared. I need to factor that, which is x plus 4 times x plus 3. Now I notice we do have a common factor. You should have noticed that. So that's going to be part of our whole. So the x coordinate of the whole is -3. So we've got -3, but let's hold off on the y. Now we would cancel out and bring down the simplified form, x minus 1 over x plus 4. The numerator was always the 0, and the denominator was the vertical asymptote, where the graph is undefined. So that means our 0 here is x is equal to 1 or 1, 0. And the vertical asymptote is x is equal to -4. So the graph would approach but never reach -4. Then now let's finish getting the y coordinate. If x is -3, what do we plug in for x? -3. So -3 minus 1 and -3 plus 4. So here we've got -4 over 1, which is -4. So you would have a hole in the graph located at the point -3, -4. So before we actually just finish up here and practice everything, remember that first graph, there was like a horizontal asymptotes. Remember, horizontal is your left and right. Now this is a little different. We're going to actually focus on the degree of both the numerator and denominator. So if we have a greater than degree, then there's no horizontal asymptote. But if the degree is less than in the numerator, then it's going to be y is equal to 0. Then if the degrees are equal to each other, we're going to set up the fraction, but using the coefficients of the numerator, which is again our top, over the denominator in the bottom. So again, if their degrees are greater than, there's no horizontal asymptote. If it's less than, y is equal to 0. And if it's equal to, you have to set up the fraction using the leading coefficients. Like for example, look at the degrees. Well, x in the numerator is just 1. Well, 1 and 2 in the denominator. 1 is less than 2. So let's go back. When it's less than, right here, it's y is equal to 0. So now to show you the graph, let's see if it's y is equal to 0. Notice how here it gets closer and closer, but never reaching 0. Again, going closer and closer, but never reaching 0. Now let's look at the second one. Again, focus on the degree. Well, the highest degree in both is 2. So 2 is equal to 2. That means when it was equal, we do have to set up using the leading coefficient. So y is equal to, our leading coefficient for that degree is 2. And what's in front here? 1. So y is equal to 2. So again, just to see if we've got that correct, we said y is equal to 2. So for the horizontal asymptote, There you go. Notice how the graph here at y is equal to 2 is getting closer and closer, but never reaching y is equal to 2. Then the last one. Again, the degree here is 3, and the degree in the denominator is 2. So comparing 3 to 2, 3 is greater than 2. So when it was greater than, we have no vertical asymptote. So there is none. So let's go back and actually see the graph. And notice how, here you go. So notice how this graph is just kind of continuing on, and it's almost as if there's no vertical asymptote because it's like one of our odd functions with that Q-drew function, where we're continuing on, and there's no break in between. So there is no horizontal asymptote. So go ahead and pause the video and try these 3 U-tries on your own. And here we go. So identifying the highest degree here, we have 3 and 1. Well, 3 is greater than 1. So when it's greater than, you have no vertical or no horizontal asymptote. Here the highest degree was 2 and 4. Well, 2 is less than 4. So when it was less than, it's just y is equal to 0. Then the last one, they are both at 2. So when they are equal to each other, you have to set up the fraction with the leading coefficient. So here I have 2 over 4, which simplified, so y is equal to 1/2. So now we're putting everything together. So go ahead and I would say try these 2 on your own, but I would first focus on the horizontal asymptote because that just does the degree. So I'm actually going to start with the horizontal asymptote and then do the other 3 characteristics that we did earlier. So go ahead and pause the video and try these on your own. And here we go. So I'm going to focus on the horizontal asymptote. Well, I notice that both are the same. When 2 is equal to 2, that's when we have the fraction set up using our coefficient. So I have 2 over 1, which that means the horizontal asymptote, y is equal to, not 1, sorry, y is equal to 2 from 2 over 1. Now let's find the others. Well, here you should have noticed, though, in the numerator, in order to factor, because it's actually a is equal to 2, which is greater, you needed to do bottoms up. We're going to factor x squared minus 3x minus 4. Well, this is x minus 4 times x plus 1. Then remember, right, whatever a was that we multiplied by, which was 2, divide by 2. So the numerator in factored form is x minus 2 times 2x plus 1, bringing that bottom up. Then in the denominator, when you factor that, the factors that multiply to get -6 and add to get 1 are +3 and -2. So now you should have noticed we do have a common factor. So that means your whole here, x is equal to 2. But again, hold off on getting the y coordinate. Now let's cross out and simplify. So I have 2x plus 1 over x plus 3. And remember, the numerator was always the 0, and the vertical asymptote was from the denominator. That means here for the 0, that is 2x plus 1, which is equal to 0. So if you were to solve for x, subtract 1, 2x is equal to -1, divide by 2. So that's how we get here. The 0 is located at -1/2. Then the vertical asymptote is approaching but never reaching the line. X is equal to -3. Now let's finish the whole. So if x is 2, that means what do we plug in for x? 2. So that's 2 times 2 plus 1 over 2 plus 3. So 2 times 2 is 4 plus 1, which is 5, over 2 plus 3, which is 5. So 5 divided by 5 is 1. So the whole is located at 2, 1. Then the second one, let's start again with the horizontal asymptote. So here they are again, equal to each other. When they're equal, you set up the fraction. So it's the leading coefficient, which is 1 over 4, which is still 1/4. So our horizontal asymptote is approaching, but y equal to 1/4. Now let's continue finding the other three characteristics. Focus on factoring. We can factor the numerator because that's a difference of two perfect squares. So x plus 3 times x minus 3. Then here we have a GCF of 4x. Then I'm going to take out and left with x plus 1. So is there a whole? No, because there's nothing in common. So there is no whole, none. That means here from the numerator, we have two zeros. X is equal to positive and negative 3. Then the vertical asymptote, we actually have two vertical asymptotes because we have two x's here. We have 4x and x plus 1. So that's like saying 4x is equal to 0 and x plus 1 is equal to 0. So that's how we have x is equal to -1, right? From the x plus 1 subtracting 1. Here you would divide by 4. And you are still left with how x is equal to 0. So x is equal to -1 and x is equal to 0. So we have two vertical asymptote lines.